practice with friction graphs. This is actually the second problem on the guided practice, but maybe we'll have time to do a couple others as well. This graph has friction on the y and a pushing force. I don't know what this P is. This should be force of pushing on the x. And so this applied force is increasing during this point. This, as we talked about, would be all the whole static friction region. And then it's staying still, staying still, staying still. It gets here, we call this the break free point. And then this is where it's constant speed, right? So here it's moving constant speed. There's a constant force during this time. This is at rest, right? So what this looks like, if it's this object, right, and it's a 10 kilogram object, so this is 10 kilograms times 9.8 meters per second squared, so this is 98 newtons, and then you've got the normal force of the surface, and then you've got this pushing force, we'll call this that FP, and you have friction opposing, then these two initially are equal, right? See, pushing and the friction force are equal. And then the friction becomes constant, okay? Even though the pushing force gets bigger and bigger and bigger. So to figure out the coefficient of friction, it's the ratio of the friction force to the normal force. The normal force of the ground doesn't change. So the net force Y equals MAY. So Fn minus Fg equals Ma. There's no acceleration up and down. So Fn is going to equal 98 newtons. So this is 98. Now, the break free point here is going to give you the static friction maximum. This force here, which looks like it's 50, right, is going to give you your kinetic friction, right, using this one. And why, right, when you're doing the friction force is going to be equal to your pushing force. So that's where you can kind of figure out what that is during this constant speed section. So this is about 0.5, and the static friction is going to be this maximum, which is 75 over 98, which is about 0.75. I'm rounding a little bit. So that's that problem. And then if you look at the next one, here's two friction versus normal force graphs. For each graph, identify the coefficients of static and kinetic friction. So how do you know just by looking? Well, they're telling you that this lighter colored one, here is your tension at constant speed, and this one is your maximum tension from each one. Generally, though, for the same surfaces, right, the static coefficient is much bigger than the kinetic. So you're going to pick the steeper line is going to give you, right, this slope is going to be your static coefficient, and your kinetic coefficient is going to be the less steep slope. That's almost always true. But it makes sense, just like when we were talking up here, because when you're dealing with the tension at constant speed, it is moving, right? You're implying there's motion, and when it's moving, it's kinetic. When you're at max tension, that's your break free point, when you're at a maximum there. So that's how we do these things. And to figure out this one, we're going to need to find the slope. So we're going to find our best fit. Oops, like that. That's one. And this one is going to be more like this, right? So here's our static. Can't tell the color very well. Here's our other one. So we can pick points. So we're going to find our slope. This is our weight, which is Fg, but we know that the weight is equal to the normal force of the surface. Here's the friction force, so the slope is going to be friction over normal. So we're going to do static friction. We can do it first. So let's pick any points you want on here. So we can use this one. We've got the y is going to be 2. Let me use this point. So it'll be 4.92. And we can do like this one, which is like 1.25, and what's that? 3. Okay, so I like to mark the points I'm using. So I use these 2 points. And then you can figure that one out. 0.75 over 1.9. Where's my calculator? .395. And then the kinetic coefficient, we're going to do it the same exact way. So I'm going to pick this point is going to be 4.9. And we'll say that's 1.25. Yeah, that's right. And then we can do any other point here. So let's do this one. Let's say we're at 1.25. Oops. Yeah, this is 3.0, and this is 0.75 would be here, so that's like 0.6-ish. Okay? Sorry, it's so messy. I'm kind of rushing a little bit. So 1.25 minus 0.6 is 0.65 divided by 1.9 is 0.342. Okay, so that's how you do that one.